Welcome, Algebra 1. This is section 6.2, solving systems using substitution. The essential question is, why is it called the substitution method? Let's begin. So this is the second of the three ways we're going to use to solve system of equations. Next one will be elimination method. Just a note, substitution and elimination are algebraic. You're just doing a bunch of algebra to actually solve it, while number one's kind of graphing with the visual. So what is substitution method? Well, substitution method is where you just substitute an expression from one equation into the other equation. So for example, I substitute this, since y equals this 3x, I substitute that 3x in for the y on the bottom equation right here. So when I substitute that in, I get a new equation that'll read x plus 3x equals negative 32. And then you solve for x, and then you can solve for y. So when would you actually use the substitution method? Well, I think this is, you don't have to, you can use it all the time, but you don't have to. It's usually easy when one equation has an isolated variable already. So for example, in the equation above, y equals 3x, well, the y was isolated. So that's an easy way to substitute. If I did an equation y equals x plus 5, the y is isolated. It's easy to substitute. In this one, it'd be easy to substitute the x into the second equation. So those are equations when it's good to substitute. If you had equations like x minus 5y equals 10 and negative x plus 2y equals 5, those aren't really that easy. If you wanted to, you could, but I wouldn't in those cases. So here's the steps for substitution. 4 steps you can follow if you don't know. So step 1, substitute one expression into the other equation. So in this example, and I did just the last slide, I substituted that 3x, because it's y is isolated, in for the y on the bottom. So then when I substitute, I get a new equation, x plus 3x equals negative 32. Now your next step is you have to solve the new equation for x. So if I want to solve that equation, what I'm going to do is I'm going to, let's see, combine like terms. 1x plus 3x is going to combine to 4x equals negative 32. And I want to solve for x and isolate the variable, so I'll divide by 4. Those cancel out, I get x equals negative 8. So I solved for one variable. Good. Now, I don't just need x, I need an ordered pair x and comma y, right? So I got to find the y. So to find the y, I substitute into one of the original equations to find the other variable. So I'm going to take that negative 8 here and substitute it into one of these originals. I don't care which one, but usually whatever one's simpler to you. You can choose either equation. I'm going to choose the top one. But guess what? I'll just do both for fun. So I can choose, let's choose the top one over here, y equals 3x. And I'm going to choose the bottom one, x plus y equals negative 32. So we're going to use both to solve. So on the y equals 3x first, I substitute a negative 8 for x. So I get y equals 3 times negative 8, which means y equals negative 24. Now if I substitute into that other equation right here, it's going to be negative 8 plus y equals negative 32. And then I would add 8 to both sides. When you add 8 to both sides, your y equals negative 24. Hey, it's the same thing. So it doesn't matter which one, it's just whatever looks easier to you. Now that you've got your x and your y, you write it as an ordered pair. You don't want to leave it like this. Write it as an ordered pair in the format x first, so negative 8, and then y second, negative 24. That is the answer. So that's how you do that. So can you always use substitution? Yeah, but sometimes it requires a lot of isolating the variable. So here's an example. You can't just substitute this into the bottom one. It has to have one of those isolated. What I could do is I could take this bottom equation, just this bottom one out here, and I could add 2x to both sides. And then I would change it into a new equation, y equals negative 3 plus 2x. And then I could substitute that negative 3 plus 2x in for the y on the top equation. Then I would get a new equation, 3 times negative 3 plus 2x plus 4x equals 14. And then continue solving. So yes, you could do that. But honestly, in this case, I would probably use the elimination method, which you're going to learn next time. But it's up to you. Alright, there we do have cases, just like in graphing, where you have infinite or no solutions. But how can you tell? Because you're not graphing it, you don't have that picture of it crossing. Well, the way you can tell with substitution method is for infinite solutions, when variables will eliminate and you'll have an equation that is true. So for example, in this case, I'm going to substitute this negative 2y plus 4 in for the x on the bottom, so this in for that x. So what I get is 3.5 times negative 2y plus 4 plus 7y equals 14. When you do that, distribute that negative 3 to the negative 2y and the plus 4. So what you're going to get is negative 7y plus 14 plus 7y equals 14. That negative 7y and positive 7y combine. Those actually cancel each other out because negative 7 plus 7 is 0y. So all you're left with is 14 equals 14. So the y's eliminated, and 14 does equal 14. That's true. So now we have infinite solutions. Now the other case of no solutions here is when variables eliminate and the equation is false. So for example, I'm going to substitute this negative 3x minus 11 in for the y on the bottom. When you do that, you're going to get 3x minus 11 minus 3x equals negative 13. If I combine like terms, the 3x and the negative 3x, they cancel out. So you're left with negative 11 equals negative 13. And that's not true at all. That's false. So nope. And then this is going to be no solutions. All right. So that's it for that. Let's try some examples. Pause the video. All right. What is the solution? Use substitution and check your answer. So I can substitute this part into the bottom or this part into the top. Either way, I'm going to choose just to substitute that into that. So what do I get when I substitute that? I'm going to get 2x plus 7 equals x minus 1. And time to solve for x, so I subtract 1x from both sides. So those cancel. I'm left with x plus 7 equals negative 1. I am going to subtract 7 on both sides. Those cancel out, and I get x equals negative 8. So there's 1. Now I've got to figure out the y, so I'll substitute into either equation. Let's choose the bottom one. So y equals x minus 1, which is going to be y equals negative 8 minus 1. So y equals negative 9. There's x, there's y. Let's write it as an ordered pair. The solution is going to be negative 8, negative 9. And that's my answer. Oh, that's it.